Okay. Good morning. My name is Amy, and thank you very much for watching. So today we are going to be going from 4 hours and 20 minutes into this 32-hour course to whenever I say that we're done. Probably at least 11:30. And then we'll have another session after lunch, and then a few more this evening. We are trying to get 4 hours of training every day, which is not going to happen. I just wanted to let you know that is not realistic. My work computer just decided to go to sleep. So if you don't know, on Friday, my company decided, or they told us that we got acquired. And I'm not... Of course, I'm having trouble logging back into me. Anyway, so we're getting acquired. I'm going to be shunted to a new company. I am a little skeptical of the signing terms of the offer letter. So I'm going to go ahead and probably just not work this week and do intense training for this instead, because I see my future in Web3 and I have not found the time to finish this course before now, but now I am motivated. So now that I've just spent 5 minutes explaining that, I've already paid the ad tax, so we should be good to go. Right now we are going through the chain link. He's going over how to use the interfaces to know what is available for us, because we're trying to get the price of Ethereum from Chainlink, because using the oracles is the only way that we know outside information like that.
Or again, 1 times 10 raised to the 18th. I'm going to deploy this to a testnet just to demonstrate it, but again, you don't have to if you don't want to wait for this. So I'm going to go ahead and deploy this, confirm, and now we have this fund me contract. If I don't say anything in value and hit the fund button, we're going to get this gas estimation error failed. This is kind of a blanket error, basically saying, hey, you can go ahead and send this transaction if you want. It's highly likely that it's not going to work. And the reason that Remix knows that it's probably not going to work is because it can see this require and simulate the transaction and say, hey, you didn't send enough money with this. However, even if we send some money, like 5,000 Wei, it'll still give us this error, because that's not enough. Let's do the calculation right now based on what the price of ETH is. So we can actually go to data.chain.link. We look and see approximately what the price is. So it looks like the price of Ethereum right now is about $3,000. And this might be different for you depending on when you do that. So if the price of Ethereum is $3,000 and our minimum is at least 50, we could do 50 divided by 3,000, 0.016 ETH should be approximately enough. So if we go to our Ethereum converter and we do 0.016, we'll get how much that is in Wei. Let's do 0.02 just to make sure that we're going to be over the amount. So we'll paste that in. We'll change this to Wei. And now if I hit the fund button, instead of us getting that error popping up, it's going to actually go ahead and let us do the fund function, and we could confirm it and it wouldn't fail. I'm going to reject it for now just because I don't really feel like waiting for the transaction to go through. But great, we've confirmed that our get conversion rate is working as intended. Awesome, great work. So what's the next bit of this funding contract that we want to do? Well, when people actually send money to the...
How can I remember getting 3 hours into this course, but also remember going through this? So I'm pretty sure I made it at least halfway through lesson 4 before crapping out last time. But hey, it helped me reconstruct the third web contract. So we got that going for us, which is nice.
This contract, we want to keep track of all the people who send us money. So let's create some data structures to keep track. Let's create an array of addresses called funders, and we'll keep adding all the funders who send money to us. So we'll say an address array or an address list. We'll make it public, funders. And anytime somebody sends us money, and this actually does indeed go through, we'll add that funder to the list. So we'll say fund.
Okay, so if we go to Remix, which probably have in a different tab, we'll go with this. So above the fund, we have minimum USD, which I would have just done min USD because that's acceptable. We're defining the address as the type, public funders, and then he's saying if we have enough, we can say like funders dot push message dot address probably. Okay, well, we'll look and see what
Funders dot push message dot sender. Like message.
Oops. Okay, so it's not address, it's sender. I'm not, I'm probably not sick, by the way. I am in allergy season. So my allergies get much worse in the fall. And I have been putting off starting my Flonase because you can only take it 6 months out of the year, so I have to be careful when I start it so that I can choose when I feel good and not. I could at some point go and see an allergist, but between Claritin and Flonase, I feel pretty human most of the time. So that's why I've been more sniffly lately too. Anyway.
Message.value, message.sender is an always available global keyword. Message.value stands for how much Ethereum or how much native blockchain currency is sent. Message.sender is the address of whoever calls the fund function. So if we're on Rinkeby, message.sender is going to be equal to whatever address is calling that function. Since our address is sending the ether, we're going to add our address to this funders list. This way we can keep track of all the wonderful donators who are donating to our contract. Then maybe we want to even make a mapping of addresses to UN256s of addresses to how much money each one of these people have actually sent.
So we're just defining it as a mapping. We'll just say like account value.
So we'll do address to UN256, public, address to amount,
Address to amount funded. If we're just being like super explicit, which is usually good in demos because you get into the foo bar situation of if you understand it, you understand it, but too sanitized and nobody knows what you're talking about.
funded. And when somebody funds our contract, we'll say address to amount funded of message.sender equals message.value. Now we have a function where people can fund our contract and we can set a value in terms of USD and we keep track of the different funders.
Okay. Message sender equals message dot value with a colon, semicolon.
Who actually fund our contract. This is fantastic. Now, I know we've gone over a lot of really intense math and intense stuff here, so let's do a quick refresher of what we've learned so far. Whenever we work with a contract, we always need the ABI and the address. When compiled, an interface gives us that minimalistic ABI to interact with contracts outside of our project. When you combine these compiled interfaces with an address, we can call the functions on that interface on that contract. Chainlink data feeds are a decentralized way to get information about the real world. In this case, we're getting the price of Ethereum in terms of USD from a decentralized collective of Chainlink nodes. When working with math in Solidity, decimals don't work. So we need to keep that in mind when doing any type of math in Solidity. And we need to make sure we always have the correct units so that our math makes sense. Message.value and message.sender are globally available variables where message.sender represents the sender of the message or transaction, and message.value represents the number of way sent with the message. There's a whole bunch of different special variables and functions that we can access at any time, and these are available in the Solidity documentation. All right, great. We've got a great way that we can actually start funding our contract. But our code looks a little bit messy. We've got a couple of different functions for getting the price and working with these prices. Is there a way to make this math a lot easier to use? This is where we're going to introduce the concept of a library. So what is a library? I definitely recommend checking out soliditybyexample.org as you're going along with this course as well. They've got some fantastic examples. One of such examples.
Did I actually, okay. Solidity by example.org, right? I think, like, if I'm going to be going through all of this, we went over inheritance, we'll be going over constructors, mapping we've gone over, enums are just like a data structure thing. Will this actually... Okay. That's fine. These are just examples, which is great. Okay. We'll go back.
Example is going to be about libraries. Libraries are similar to contracts, but you can't declare any state variables and you can't send ether. We can also use libraries to add more functionality to different values. What do I mean by that? Well, what we can do actually is we can have get conversion rate be a function of a uint 256. So we could do something like message.value.get conversion rate. And we can add functions as if uint 256 was an object or a struct or a contract that we actually created. So how do we do this? Well, let's create a new contract in our contracts folder. We're going to create a new file. We're going to call it price converter.sol.
Okay. I kind of remember doing this. Everything is I sort of remember. This is kind of familiar. What are we doing? I prefer how View Mastery does their courses, which I haven't done any of their courses in a while. But basically, they take the transcript and they put it in blog format, and I can follow the blog, and when I get stuck, then I watch the video, and it's usually less frustrating for me personally. There's just something about listening. Like, this isn't even, like, I can be in Twitter Spaces for, like, let's not even talk about how long I'm in Twitter Spaces per month. But I don't have to have 100% concentration when I'm there either. So this is definitely exhausting. I actually woke up like 2 hours before my alarm today. I was kind of angry about it. But anyway.
And our price converter.sol is going to be a library that we're going to attach to a uint256. So how do you actually create a library? And what is a library? Well, a library is going to be really, really similar to a smart contract. It's going to start with SPDX, license identifier, MIT. We're going to give it a pragma solidity.
I bet you it says library instead of contract.
And instead of typing contract for the name of the contract, we're going to do library.
Wow. Okay. This makes sense. Library. I know what a library is. It is where you go to read.
For the name of the library. We're going to call it price converter. Now, libraries can't have any state variables, and they also can't send either. And all the functions in a library are going to be internal. So what we can do is we can go back to fundme.sol. We can grab get price, get version, and get conversion rate, copy them all, delete them from fundme.sol, and pick.
Okay, so I think we only filled out the one, right? Get price, get conversion. And fund? Not fund. We'll just get these two. And sorry, what are we doing?
.sol. We can grab get price, get version, and get conversion rate, copy them all, delete them from fundme.sol.
I think I just didn't do get version, which is very helpful when you're specifically following along. So yeah, these two can now be gone. Price converter. Into the library we go. I don't know if you saw it, but my cat is now happily in the laps. Really? Okay. Unsure how we're supposed to use this if it's not defined, but well, I'm just gonna trust the process.
And paste them into our library. And of course, since we're using aggregator v3 interface in here, We can also copy the import from FundMe, and since we're not using the aggregator v3 interface in our contract anymore, we're using it in our price converter, we can paste it into our price converter. Now, if we compile priceconverter.sol, we see that it actually passes. Now, all the
Okay, but I tried to get rid of it before. Oh, baby, I love you. Okay. Cat does not like that I leaned forward. Too much leaning going on here. I think maybe I should have closed this. Yeah, I'm pretty sure I've been putting that in the wrong spot anyway. So there's that. Anyway, we don't need that stuff in here anymore. So good. We have the right things in the right places now. Go us.
functions inside of our library need to be internal. And we're going to make this library price converter different functions we can call on Uint 256. For example, we're going to be able to do message.value.getConversionRate. We're going to directly be able to get the conversion rate of a value of a Uint 256 as if that was a function for it the whole time. So first, let's make this internal. Let's make getConversionRate internal. And
Okay, so instead of public, what are we doing? No, I don't have a weight loss goal. What? We're just going to internally deal with my feelings on that. Okay. Then
we'll make getVersion internal. Now that we have this library price converter back in our FundMe, we can now import this price converter and attach it to Uint 256. So we'll do import./priceconverter.sol. And in FundMe, we'll do using.
okay. So now I'm actually thinking about little work things. So there's that. This is price converter. Let's go into the real rightful file. Blech. Import price converter dot sol, which I should stop using single quotes. That is JavaScript, lizard brain. Import price converter dot sol, and then in here, inside of the contract, but outside of any functions, we're going to start doing using price converter. Uh-oh.
Price converter or
For Uint 256.
Uint 256. Of course, if we compile our FundMe now, this line is getting an issue because it's saying, hey, getConversionRate isn't defined. Now in our library, the first variable that gets passed to the function is going to be the object that it's called on itself. So in fundme.sol, let's go ahead and comment out this line for now. If we do message.value.getConversionRate, this is secretly the same as if we did getConversionRate of message.value. In our price converter library, the message.value is going to be passed as the input parameter to getConversionRate. For getPrice and getVersion, we don't really care about the number, so we're just going to leave it blank for now. So instead of require getConversion,
So inside of the fund, if we instead of this, we can do get, oh, So minimum USD, and then we do get conversion rate. Nope. Stop doing shortcuts. They're the long way. And then get conversion rate. Well, first of all, that's not where that goes. That might help. Did not help. Okay, so get conversion rate. Okay, so that does not work for some reason. Do I need the thing above it?
Conversion rate of message.value, we can now do message.value.get conversion.
Okay. We were just between things, and I got all hyper. See, if you call it correctly, it'll work.
On rate and compile that. You'll see that here we're not passing a variable, even though our get conversion rate function says, hey, I'm expecting a variable. Again, the reason for this is this message.value is considered the first parameter for any of these library functions, and that's how it works. If we wanted another variable in here, like uint256, something else, now we would want to pass something else in here, 123, and this 123 would get assigned to this.
See, now that's important because the first variable is like what it's chained to, but anything else needs to be defined within the parentheses. So something to take note of.
Something else, but we're going to delete that for now. Okay, great. And in doing that, we've minimized our FundMe contract a lot by moving a lot of that math and price conversion stuff into our price converter library.sol. One of the most common libraries that was used for the longest time was this library called safemath.sol. And you'll probably see it a lot of different places. We're going to go off on a quick little tangent here and teach you about safe math. So let's close FundMe and close Price Converter. And let's create a new file called safemath.tester.sol. And let's start with some basic stuff in here. Safe math was all over the place before version 0.8 of Solidity, and now it's almost in no contracts. What happened? Why is safe math no longer used as much? Well, let's create a sample contract. This is a section that you don't have to follow along if you don't want to code along with me, but if you want to, you absolutely still can. This is going to be...
Yeah, so we'll get through this section, and then I'm going to log into work and say some stuff, and then not work, and then go do lunch, and then I will be back, probably, until it's time for the meeting that I have today at 3 p.m. that is discussing the benefits of my new job, which, even though I'm a little, I would say just dissatisfied with some of the terms of our benefits, it's really not fair to me to say like, oh, well, you know, we're just gonna continue your contract the way it's always been, and then just have less benefits that, you know, impact me with thousands of dollars. It's not my fault I got acquired. So, however, the U.S. economy, we are heading into a recession, so any job is better than no job. Except I'm trying to learn this so that I can become a developer advocate, so that I can do my own stuff and develop my own things and show people how to use whatever we're doing, and just, you know, be paid to do my own thing, which is great. I like doing small things and just, you know, it's okay. It's all right. That's the goal. That's what we're doing. We're getting through this. It shouldn't take too long. I'm the sort of person that always has to look at the end of the book and be like, how many more pages to this chapter? How many more? Okay. So we are like halfway through lesson 4, which is not bad. I've never used Ethers.js simple storage, I'm pretty sure. So we've never made it to lesson 5. So that will be a really cool milestone if I can get to that today. And then it looks like we're just going to be doing lesson 5 to the end of time, because it's a 3-hour lesson. So, what is the difference between ether? Is this a dumb question? What is Ethers.js? Ethereum text system. Keep your private keys in your client safe and sound. Import JSON files. Import. I'm assuming that they're assuming that if you made it this far, you know why you're doing Ethers. I think this might be a programming thing and not an IPFS thing, which is weird. What's the difference between, like, is some of this it's hard hat like a type of IPFS, or one of these things has to be interplanetary file system something, because it, like, your files have to be stored somewhere doing something. I don't want to be a back-end developer, but I do think it's important for me to know how it's going. This is why it takes forever for me to get through these courses, because then I'm like on a tangent. I already told you, let's get through the Safe Math Tester, which basically before version 8 it wasn't included, but in 8 moving forward it's just an included library, so we don't need it anymore.
Contract we are going to deploy on a JavaScript virtual machine. We can use any version of Solidity before version 0.8 of Solidity. So, for example, we'll use pragma caret 0.6.0, and we'll create contract safe math tester.sol. Now, if I create a uint 8, I set it to public big number, and I set this to 255. Oops, safe math tester. Let's go ahead and compile safe math tester with 0.6.7 pragma solidity. The maximum size of a uint 8 is going to be 255. This is going to be the biggest number that we can fit in a uint 8. And if I were to deploy this to a JavaScript VM or even a test network, safe math tester, let's go ahead and deploy it. If I hit big number, we're going to get 255. Well, what happens if I create a function called...
So when you add 1, it resets to 0, which is really sad, because you don't want all of your money to revert back to 0 if it's too large. That's a scam.
Add that sets big number equal to big number plus 1. Let's save that, delete that old contract, and deploy. Well, right now, big number is 255. What happens when we add 1 to big number, when 255 is the max size a uint 8 can be? Well, let's hit add. Now let's check what big number is. Big number gets reset to 0. So what's going on? Well, prior to version 0.8 of Solidity, unsigned integers and integers ran on this concept of being unchecked, which means that if you passed the upper limit of a number, it would just wrap around and start back from the lowest number it could be. So if I call add a whole bunch more times and hit big number, now it's 8. If I were to hit this add button a ton more times and get it back to 255, it would then continue to wrap over to 0. So one of the most popular libraries that was out there was this safe math library, which would basically check to make sure that you weren't wrapping around a uint 256 or an int 256. Basically, it was a way to say, hey, you've reached the max this number can be, and now your transaction is going to fail. If we switch this to 0.8 of Solidity, delete the old contract, we'll go switch this to 0.8, we'll go ahead and compile it, and now we deploy this to a JavaScript VM. If I hit big number, we get 255, but if we hit add, it actually fails, and we still get 255. In version 0.8 of Solidity, they added this bit where it automatically checks to make sure if you're going to do what's called overflow or underflow on a variable. We can actually revert back to the unchecked version by using an unchecked keyword. So if we wrap this big number equals big number plus 1 in this unchecked bracket, let's delete our old contract, we'll compile, we'll redeploy. We hit big numbers, 255. Now we hit add, we hit big number again, it reverted back to 0. So that's a little bit more about safe math, checked and unchecked. So in version 0.76 and below, this code that you see in front of you is going to be the exact same as this code in 0.8 and above with this unchecked keyword. Now you might be thinking, in newer versions of Solidity, why would I use this unchecked keyword? Well, you'll find out later that this unchecked keyword makes your code a little bit more gas efficient. So if you're absolutely positive that your math is never going to reach the top or bottom limits of a number, then it might make sense for you to use the unchecked keyword. Let's head back over to our FundMe contract, where we are now using the price converter library that we just created.
Okay, so we're gonna do the basic Solidity for loop later at 4 hours, 34 minutes, and 31 seconds. Later today. Yeah, I would really like to get to lesson 5 today, and maybe not through lesson 5. That's a little ambitious, but we're working on it, and that's the best that I can do. I'm not going to beat myself up no matter how much or how little we get through this week. It's just we're we're shooting for consistency here and me understanding what is going on. Because, like, there's no point in me going through this 32-hour course and not understanding what's happening. And also, the reason why I'm going through this course and not just, like, going through and making my own project first is I think it's more efficient for my time to go through a course like this where they actually go through everything I need to know, instead of having like Swiss cheese learning and having huge blind spots on how things are supposed to work. And plus, like, with Solidity and contracts, this is involving money. So, of course, when things involve money and you're not just using like Stripe, you have to pay attention and do it correctly, because, I mean, it's a lot of money and you need to understand what's going on. So, anyway, if you're watching, thank you so much. Please like and comment. Let me know if any of this didn't make sense, and I will attempt to get you answers. But this is mostly a journey for myself, so thank you for coming. And I will see you later today.